Packet lesson 1-3, day 1, pre-calc B. Here we go. The 12 basic functions. Again, cannot encourage you enough to watch the pre-lesson. It's going to do you a ton of good. So we're just going to dive right into these sample problems here. Warm you up. This guy right here is going to be x equals some number. What number? Well, let's just say it's like, if this is my y-axis, this is my x-axis, this would be like, let's just say 3 to the right. So it'd be 3. X equals 3. Now it'd be an asymptote if there was some graph that was trying to get to it, but it just couldn't. Horizontal, let's do this, 1, 2. And so now we know its name, it's y equals 2. It's an asymptote if it's kind of like a roof. Like it just can't get there, okay? Keep that in mind. And now we're going to go with this. Wish I could zoom in big time. I will try to focus in, but hopefully you can see this says x approaches infinity. That is your fancy, this is calculus's way of it seems fancy, saying, hey, move along the graph left to right, because we know that positive infinity is that way. So think of it as a roller coaster. Now think range, because that's what this whole thing is asking you about. What is the range? Well, that's the y value. And if I go left to right, it's going up, 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 up. So this would be positive infinity. How about this guy? What's the difference? Well, I don't know if you can see it, but that right there says as x approaches negative infinity, which means we need to move right to left along this graph. By the way, this was left to right, okay? This is a fancy way of just saying move right to left. Okay, I'm going to pick a random spot right here. Think of it as a roller coaster. Uh-oh, scary, going down. So my answer to this whole thing is negative infinity, because it's about the range, the ultimate, where does this roller coaster ride end? Down, 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 down. Okay, that's why my answer is negative infinity. All right, now we're going to get into some other things. I might have to pause this, but identity function is just f of x equals x. Okay, you want to write this down. That's a different way of just saying y equals x, but I'm not going to do that every single time. Squaring function is just your parabola. So we got f of x equals x squared. Cubing function, that is y equals x cubed. Pretty straightforward. I showed you that one in the pre-lesson. The reciprocal function, this is f of x equals 1 over x. Square root function, this is y equals the square root of x. That's why there's no negatives in our x's, because you can't have a negative in your domain. Exponential function. And right here we have the exponential function, which we are going to call, there's different variations, but this class is going to refer to as f of x equals e to the x. And then we're going to go on to these last 6 here. You got to know what they're called. So do you have to have these memorized? No. Will you have these available to you on your tests and quizzes? Yes. Y equals ln x. All right, that's natural log, but they flipped these for a reason. I'll explain that later. We should be familiar with this. Y equals sine of x. Cosine, let's mix it up. F of x equals cosine of x. Absolute value function, f of x, pretty straightforward. Absolute value of x. Greatest integer function, this one's a bizarre one. This is y equals, and that stands for integer of x. So if I put in like a 2.1, it would convert it to 2. It just converts it to an integer. That's why these are all whole numbers. Anyways, logistics, this is a weird one. F of x equals 1 over e to the x plus 1. And that's it, guys, for your 12 basic functions. Now, what are we supposed to do with all this? Well, first of all, be familiar with them, because like I said in the pre-lesson, you're going to have to do some matching. So let's just get one right out of the way. Number two, I can tell that this has either got to be sine or cosine. So, well, because I have a cosine here and a sine here, I know this one would be like this, and then it would move up one, so it would really be like this. Sorry about the butchered drawing, and that's really not what this is. So this one has to be connected to cosine. So that's what you're doing. But let's dig a little deeper. What does cosine look like? Like the original cosine? The original cosine would look something like this, if you remember. Okay? So what does this negative do? Well, this negative would flip it over the x. That's why this is down here. This is up here. This is up here. Basically, here it is right here. Okay? So I know that 2 would be L, just based on what we've learned in previous lessons. So that's what you're going to basically have to do, manipulate and discover which graphs go with each. So you can tell that this one's a cubic one that's been moved to the right. See, I'm doing your homework for you. 1, 2, 3. Well, I think that's, I shouldn't have written on there, but 3. So this is built off y equals x cubed, but it needs to be to the right, so it'd be minus 3 cubed, and I need to go looking for that, and that would be right here, letter F. So that's how you're going to attack your, so you don't have to know everything about every graph, but with that being said, you also need to, for the homework, be able to answer these generic questions. Now, we've talked a lot about this in the pre-lesson, so I'm not going to review it now, but we have what's called a basic function, the absolute value function, which is right here. Now, what's the domain? Well, again, this is asking you how far left does it go, how far right does it go, and you might have parentheses, you might have a bracket, but it depends on what the graph looks like. Well, again, I know the arrow wants you to think up. You have to fight that. It's asking you right now, if you continued on this journey, how far to the left would you go? Well, that would be negative infinity. Why parentheses? Because you can't get there, according to math. How far to the right would this go? In other words, how wide would this continue going? Well, that would be positive infinity. Range. This is asking you to go low, and then how high? Well, this one, I can tell there's going to be a bracket around the low and parentheses around the high. So how low does it go? Well, it goes down to 0 on my y-axis. So that's what I'm going to put in here. How high does it go? Well, it just goes up and up and up and up and up forever and ever. That's parentheses. Continuity. Basically, is it continuous? Yes. Decreasing or increasing? Remember, you have to go left to right in order to answer this correctly. So this is strange. Some people would say, well, for half of it, you'd be going down. And they're not wrong. And then for half of it, it would be going up. But ultimately, it would be increasing. So we'll call this increasing, but I know we could split hairs and say, well, it's decreasing from negative infinity to 0, then it's increasing from 0 up. But let's just go with this ultimate going up. Is there a horizontal asymptote? No. Now some students say, well, yeah, it is. It's right here. No, because it touches it. So this does not have a vertical or horizontal, and it doesn't have a vertical one either. In this fancy talk, you got to look at this first. That says x approaches negative infinity. In other words, you got to move left on the graph. The question is, what's the range? In other words, where's it going? Up or down or what? As I move left. So I pick a random spot, move left, 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 left. Look at it, it's going up. So my answer for the range would be infinity. Now this says, all right, go the other way. Move to the right. So I start anywhere, and I move along to the right. What's my range? Here it is. It's going up, both sides. That's pretty much it, guys. Good luck with your matching and get to know those graphs a little bit.